Kia ora team, how are we doing today? Excellent answers so far in the chat from what I can see. If you're watching this retrospectively, you're welcome to try and pause and give a little bit of an answer prior to me giving an answer right now. So if you want to do that, you can pause. So an exogenous environmental cue. Exogenous refers to outside of the body. So you could just say an exogenous cue. Environment's kind of not an entirely necessary word, but it's a useful thing to think about. A good example of this, as Fiona said in the chat, was the sun. Would be an example of an exogenous environmental cue that organisms might use. And reasons why it might be advantageous? Well, if you know when the sun is coming out, then you can get up preemptively and start foraging for food. You can know and create certain chemical pathways and go down certain metabolic pathways at certain times of day to maximize the things that will be available to you. It can influence behaviors, it can influence chemistry. There's all sorts of ways why this might be useful. As long as you can think of one example, then you're in the right ballpark for what we're going to be doing today. If all the volume is coming through all clearly, could you let me know in the chat, please? Internet's running a little bit shoddy on my end, but hopefully it's still coming through reasonably clearly. So let me know if that's not working. Thank you, Alex. All good. Looks like we're good to go. So what we will be working on today is a little bit of stuff on actograms. But firstly, we're going to be talking about our work for this week. Rightio. So Miss McNair, you will have noticed, has posted 2 lessons for you to work through. The slides for today are adapted directly from hers. So if you've gone through her slides, there's probably not a great deal of point in going back over the slides that are here. I think hers are perfectly good. What you'll also notice is that Miss McNair has supplemented a video based on the first half of these slides. This is the first time that she's done something like that, so she'd appreciate your feedback. If you think it's good, that's great. If you think it's not, let her know. I will put an extra question for next week's weekly reflections, allowing you to answer that so I can pass on that information to her. I think this is a new time for a lot of us. I know a lot of teachers are trying new things. Anything you can do to support us, tell us what works and what doesn't, is really useful information for us. So thank you for that. Also, you will have noticed that there's an activity for you to complete on actograms. That activity is an example of a question. And what we're going to ask is that you please submit your answer to that, even if you're not feeling super confident about the answer you've produced. It's okay to get things wrong, just the same as it would be in class. I would expect you to hand in a piece of paper with a few randomly written words on it, more than I would expect you to hand in nothing. It's useful info for us in terms of our teaching. It's also useful to see how you guys are learning, how your understanding is going. It also, we can use that information along with other stuff to put together sort of a package of what we can best do to support you. Lastly, just a little bit about our schedule. So we're streaming today, and we're going to have a Google Meet if you're in my class. We're going to have a Google Meet office hours this Friday at 12:35. That is optional. You can tune into it if you want for my class. I'd love to see you there. If you're available, you can ask questions. We can just have a bit of a corridor. If there's enough of us, maybe we'll do a bit of a Kahoot. I think that'll be fun. Miss McNair's very nicely put together an example of a Kahoot that we can use. So we'll probably do a bit of that. So if you like a bit of fun at around midday on Friday, love to see you there. All right. Before we move on, I'll check there's no questions in the chat. If you're watching this in hindsight and you've got questions, you can post them in the comments. I get notified of those. But it looks like we're good to go. Little bit weird lighting in this room, the way that it tends to come in. It tends to land exactly on the top of my hair, which is not super helpful, but you know, what can we do? Not a whole lot, but that's okay. Not that I'm actually in a random room in my house. I'm actually in school, in the virtual learning environment, as you can tell from my desk and from the whiteboard and everything else. Yeah, Okay, anyway, let's move on. Okay, I'll pull this up. All right, actograms. So, and immediately I've got a typo. So I'll change that. Not activity, actograms. That's always a good way to start, isn't it? Okay. Actograms are diagrams of periods of activity and rest in animals' routines. I like to think of these diagrams kind of like Fitbits, and I know a number of you kids will have sort of watches that kind of do this for you and give you these sort of diagrams of when you're doing lots of movement and when you're not. These diagrams are really useful for us in science, because they, in particular in biology, because they allow us to see when organisms are active and when they're not. In this example on the right, we can see an example at the top of normal circadian daily rhythms. So circadian, about a day rhythms, while the organism has access to a zeitgeber. So here we've got a cockroach, and we've recorded when they're active and when they're not active. Down here we can see little spikes of activity when the cockroach is running about a bunch. In the first 10 days, you'll see that they're exposed to light, and then darkness, and then light. You can imagine this is a 24-hour cycle. So you've got 6 hours of light, 12 hours of darkness, another 6 hours of light each day. What you'll see is that the periods where the cockroach is most active is mostly during the phase where it's dark. That indicates that the cockroach's normal circadian rhythm is nocturnal. It's most active each day at nighttime, which is fantastic. It's really valuable for us to know that. What you'll also see is that under certain conditions, we see a thing called free running. Hopefully we're familiar with this at this point. That is that concept that you have an internal clock and it keeps ticking. Maybe not perfectly in tune with the environmental cue, but it still keeps ticking, and over time the two get out of phase if it doesn't have a mechanism to reset, if we don't have a mechanism to reset that clock. You can see here that after 10 days, the cockroach was placed in constant darkness. And what you see is that that clock keeps ticking. There's still a time in the day when the cockroach tends to get up and be really active. But over time, that tends to slip. And this sort of classic angled trajectory is a really clear example of free running. So hopefully that's all good for you guys, and we're aware of this. It is possible to calculate what this angle is and to do some really fancy maths with that. That's a really useful thing for scientists to do. Very fortunately for you guys, we don't ask you to do that anymore. We used to, but we don't now. Okay. Some more information in here. Here we have it again, represented in a different way, and hopefully written out in a way that's clear to you using the terms that you should be familiar with. Hopefully you are aware of the term zeitgeber or time giver. Okay, yeah. Hopefully you should be all good with that. Hopefully you should all be aware of the words exogenous and endogenous. If you need to, you might need to go back to your terms list and take a look at those and maybe update them if you need to. There might be some that you have missed. We can see normal environment, we've got that entrainment, that daily cue, and we can tell that when you remove that and you place an organism in a constant environment, we see this phase shift over time, this free running of the organism running to its own internal rhythm. There we go. Okay, what happens if we introduce the exogenous cue again? What happens if we turn back on the light and dark? And what we see is that the activity pattern shifts back. The cue entrains, it resets that internal clock, and sometimes that takes a couple of days. So you might see examples where they go back to a normal rhythm, and you see that it takes a couple of days. We experience this in the form of jet lag. So if you've ever done this to yourself by traveling overseas, not that you would be doing it at any time recently, but if you have, you might have experienced this effect for yourself. You will also have experienced this effect if you've spent a whole bunch of time staying up really late at night on your phone. that is a perfect example where you're giving yourself a stimulus, saying, yes, the sun's still out, even though it's 2 in the morning. And all of a sudden, you feel like you need to really sleep in. As soon as you stop that pattern, you might need to take a couple of days for your body to reset. You've effectively given yourself jet lag. And that all comes down to these internal rhythms, these internal cues, and about how we entrain them, what Zeitgebers we give, and about how we are resetting our internal clock. So something for you guys to be thinking about. There's a lovely example here with a flying squirrel, which is a very cute organism. Fantastic video down here if you want to go and have a look at that at a later point, looking at these very cute organisms and how they behave. There's also a really good video down here, which this is taken from, which shows actograms relating to this squirrel's behavior. And what we see is a classic example of nocturnal behavior, most active during the dark. And in constant darkness, we see periods of activity, but that these shift over time. What we also see, and this is like a little bit of an extra for experts thing, is the shattering of the clock that occurs much later on. Essentially, if you don't have an environmental cue for a long time and you're expecting one, you end up with these really weird behaviors starting to emerge in terms of activity patterns. And that can be really detrimental for an organism's health, which is why we try and keep our entrainment available. So something for you guys to have a look at if you're feeling like a little bit of an extra for experts is what happens after prolonged constant environments. And there's some really good content out there for you. So summary so far, here's a little bit of a page. Hopefully you're familiar with all of this. All of this is making sense to you. If it is, that's great. If it's not, maybe take a pause, go and Google those things you don't know. All right, moving on. An example of a question from 2019. So this is the same question that is in Miss McNair's slides. So if you've had a look at these already, hopefully you'll be familiar with this. So the question, this is actually the question from the 2019 exam, and it was testing the understanding of acronyms and being able to interpret what those mean and explain those in clear words. So the great spotted kiwi, or roroa, is a species of kiwi endemic to the South Island of New Zealand. In an experiment, their activity was observed for 10 days in normal environmental conditions, and then they were moved into constant darkness after day 10. The results are displayed in the actogram here. And you can see that here, 10 days worth of activity, and then you see this phase shift. Interesting. That's starting to tell us something. Ms. McNair has fortunately gone through and put some important details here. So you've got to be thinking about describing the pattern and thinking about how is this pattern of activity controlled? What's on here? It's really valuable for you to be using the correct terminology as well. So talking about the exogenous environmental cues, talking about its normal pattern of behavior. Remember, kiwis are nocturnal. They're most active during the night. If we can imagine this is midnight and this is midnight the following day, this is midday, we can see those periods of activity occurring approximately during the night. Makes a lot of sense, right? So there's some more information here. This is relating to exactly how you answer that question. I'm just going to double check the chat, make sure there's no burning. One of the things a little bit unfortunate is that my computer's still a little bit slow. I've switched to using the webcam on the camera, which hopefully is providing a high enough quality video for you guys to work from without as much latency. Let me know if that's all working out for you guys. So what we've got here is just to go back to that, in the chat right now, which is good, is some examples of the sorts of things you'd need to get achieved or merit. Here, you're welcome to refer to these. There's also some things included here about getting yourself up to that excellence level. Discussing the pattern which allows Kiwi to survive and thrive within their niche. It is really important for you to be able to think about the implications of these behaviors on the adaptability and survivability of these organisms. What is the Kiwi's ecological niche is what you should be thinking, and how does being able to entrain to the sun or to darkness allow the organism to survive effectively? That's where you should be looking for, passing on its genes. the goal of all of biology. All right. There's some notes here. Exactly what I said before. Calculating free running periods is not an essential component. It did used to be. And if you're interested in that sort of thing, that's what you can pursue in tertiary study if you're interested in this kind of stuff. I think it's a really interesting area of study. So if you're interested in that, well worth a Google. You tend to get this as part of a question, part of a larger question, usually on behavior. So it's important to be able to relate these to some of the learning that you've had across this topic, across this achievement standard, and be able to integrate your understanding of actograms into a more complex answer. There's that point here. Discuss how the great spotted kiwi's behaviors help it to survive in its ecological niche. So you're using that actogram information to support the wider answer, as opposed to it being a question on actograms specifically, removed of context. The link to the question is down there, which you're welcome to use if you'd like to answer it directly as it was presented to the kids last year. All right. There's an example of another question for you. So it's a question from 2018. And there's some bullet points about the types of things you want to include in your answer. Again, you're seeing another really lovely actogram. You're seeing a different kind of phase shift to what you would have seen previously. And we have some notes on the next slide relating to how you might interpret these little markings that you're seeing on the sides. So LD refers to the normal cycle. DD means constant darkness. What they're saying is at that point there, above that line, there was a normal light, dark cycle. And below that point, you went into constant darkness, dark. These terms are used because that sort of 12 hours of one thing, 12 hours of another is a commonly used thing within labs. Sometimes, though, when you're looking at what the trigger is, you won't use 12 hours of each. You'll actually just give sporadic bursts of light. And often what you're looking at there, or sporadic bursts of darkness, is the exact triggers, the exact quantified environmental cues that are used to tell the clock to reset. It's a really interesting area, and if you're interested in it, well worth a look. What Ms. McNair has done, which is also very lovely, is include a bit of a structure for your answers. This is something you might want to use for other questions as well, but it's something for you to have a bit of a think about in terms of laying out your points very logically. So the suggestion is start by describing the activity pattern and how it's controlled, which is kind of what it is in here. So the activity pattern considered in the normal condition is blank, and the rhythm can be described as a da-da-da rhythm. If you're using the terminology, that's fantastic. You want to say it is controlled by, it is constrained or set by. So we're talking about our receptors there, and we're talking about our exogenous environmental cues, our Zeitgeber specifically. You want to talk about what's happening in constant darkness, what's happening in that DD condition where your cue is removed. Then you want to discuss those adaptive advantages. Why does having a rhythm benefit the organism? For example, the nocturnal pattern, activity pattern allows mice to ... And there are a variety of things there. If we're thinking about mice, we're thinking about things like avoiding predators. We're thinking about things like when their food is most accessible. So lots of reasons you could probably think of. Sometimes if we're looking at certain organisms, it's about how harsh their environment is. Maybe it's really, really hot in the middle of the day. All things for you to look at. Lastly, Ms. McNair has included an example answer to that mice question for you to have a look at. Hopefully that will be useful for you to understand. And you have some time this week to try and answer that along with the question that is posted as the assignment on Google Classroom. Okay, with all of that said, what we're now going to do is a little bit of a quizzes, just to wrap it up for today. Additionally, I've put a link here. I'll make these slides available to you guys, but there is some extension reading if you're interested on forest and bird, on wildlife that is active at night in New Zealand. You might find this really interesting. So what I'm going to do now is switch views. Hopefully this works. And we're going to play a live game of quizzes. Love to have you join in if you're able to. We'll get this popping up for you to be able to see. Hopefully you should be able to see that code now. I'll double check that everything is working, that I've got everything set up. Looks like it's working. So hopefully you can start joining now. Please use your real names, because if you're using your real names, then I can see who's understanding it and who's not. If you don't want to use your normal name, you don't have to. Please don't be rude though. I'll give you maybe a minute or two to get in there. And I'll post the code in the chat in case you're looking at this at a low resolution. Let's have a look at that code. 303052. Okay, I'll give you guys another minute or so to join up. Okay, that code is posted in the chat. Hoping very desperately we don't get stream jumped at this point, because this would be probably the worst time to have a bunch of randoms join and use rude names. I can see there's 4 of you in at the moment, which is fantastic. If you've got any questions relating to the content from this week, or any questions relating to our learning, you can post them in the chat now or during the game, and I'll try and answer them as we go. Awesome to see you here, Fraser, Luke, Elliot, Fiona, Yvette. This is fantastic. If there's any of you struggling to get in, you really do want to get in, post something frantic in the chat that lets me know that you're taking your time to get in. If you're watching this in retrospect, you can play this quizzes. It's linked in the slides. It is absolutely okay if you've joined late to this. Just do it to the best of your ability. Hopefully a lot of the content is familiar from the stuff we did before we went into lockdown. Okay, I'm going to give you about 30 more seconds, and then we're going to start up. Okay, let's get started. Lovely to see you here, Rebecca and Maddie as well. I think hopefully these questions aren't too hard. This is always the time when my computer really struggles, but hopefully we will get through. Just while you're working on this, I'll tell you that earlier today I did 2 streams. One with the earlier today I did a stream with the Year 10s, and on Monday I did a stream with the Year 9s, where we did a what's it called? Who Wants to Be a Millionaire style stream with the music and everything. So if you guys would be interested in that, I'm happy to put one of those together for you guys some upcoming week. We did it for them because they had a test coming up this Friday. Very good work, Elliot. Well done, Fraser. Well done, Yvette. Luke as well. We're all neck and neck. Fiona just jumped up. Excellent. Just while you're working through this, I will pop up some of the questions, have a look at them, see how you're doing. There's some tricky ones in here. Hopefully we're all familiar with these terms, crepuscular, nocturnal. I know we had a bit of difficulty before the end of lockdown in them, but hopefully we're familiar with those and when to use them. That's a really important thing for when you sit this exam at the end of the year. You guys are doing excellently on this, which is fantastic. Let's have a look at the leaderboard, see how we're doing. Okay. Fiona, absolutely on fire. Fraser, very, very good job. Elliot, doing well. Rebecca, also going good. Same with you, Yvette. Luke, Maddie, excellent work. Just check there's no questions on our Google Hangouts. Looks like we're all doing okay. Okay, I think we'll go for another 3 minutes, then we might have to call an end to this. You guys are doing excellently though, very well done. Very well done, Fiona. Well done, Elliot, as well, for getting through all those questions. If there's any in there that weren't related to the content that we've gone through, that's okay. Hopefully, though, it's pointed out some areas for you guys to do a bit more work on. It's nice to see that our accuracy overall is not too bad. For Fraser, Yvette, and Rebecca, good luck. You're all neck and neck, which is fantastic. You were well out in front at the beginning, Elliot, but that's okay. It's about slow and steady wins the race. Just while we're coming to a close here, I think all of you have filled out the Google form, which is fantastic. But if anyone who watches this has not filled out the Google form on Google Classroom, there's one thing I want you to do this week. It's that, because I'm going to use that as our proxy for a role. So if you could very much please go on to Google Classroom, fill out that Google form, let me know what your weekly reflections are, but also any ways that we can improve this going forward. That would be really helpful. We'll give it another 10 seconds just to let Luke finish, see if he overtakes Fraser and Yvette. Lastly, just a little reminder for Friday at 12:35, I believe, we will be doing a bit of a Google Hangout, Google Meet. That link is at the top of our Google Classroom page, so I'd love to see you there if you can make it. Let's just end the game here, give the winners their congratulatory time. Well done, Yvette, well done, Rebecca, well done, Fiona. Excellent work. Okay, let's flick back here. So I think that brings us to a conclusion for today. Hopefully we're feeling reasonably confident with our reading and interpreting actograms. If we need to spend some more time on that, you're more than welcome to do so. Essentially, that's us for today. And I'll see you on Friday. Have a lovely rest of your day. Don't work too hard. And I look forward to hopefully seeing all of you in the not too distant future. All right, catch you all later.